Hi, my name is Liam Savage, and I'm the project manager of the best electronic engineering team in the world. BLAR was established in 2014, known by our iconic logo, the resistor beam. We were approached by GCHQ to redesign the Hayphone, an underground communication system developed in the 1990s. It uses voice to communicate with an underground caver and the surface team above. The BLARphone offers text communications. This is the addition of much longer transmission distances. There is also the additional feature of the beacon mode. This sends a constant pulse into the ground, sounded as an alarm on the receiving BLARphone above. This is an open source project, meaning anyone can build it as and when required. This makes the caving community feel much safer in the hands of BLAR.
Hi, I'm Andy Reid and I worked on the hardware side of the project, including amplifier design and building the final PCBs. The BLARphone communicates through the earth using a method known as current injection. A 30 kHz signal is modulated using differential phase shift keying and then matched to the impedance of the ground using a transformer. The BLARphone is connected to the ground using ground probes or tent pegs, which allows the signals to propagate through the earth to another BLARphone. This radio can pick up the signals using a similar configuration with signal levels down to 50 microvolts peak to peak. Bye.
Oh hi, I didn't see you there. I'm Ben Brown and I'm Software Sub-Team Manager for Team BLAR. And this is the BLARphone. The BLARphone includes two internal microcontrollers. One microcontroller is for the encoding and decoding, modulation and demodulation of the received and transmitted signals. The second is for the interface between the LCD and the keyboard. I was in charge of the modulation and demodulation side of the BLARphone. Team BLAR decided to use DPSK, which stands for differential phase shift keying to encode the signal. This was then decoded using an RDFT, which stands for recursive discrete Fourier transform, which is a far faster method than the discrete Fourier transform. This allows for extremely high quality transmitted signals to be in low SNR environments with lots of noise to be detected. The bits are determined by changes in phase calculated by the RDFT.
Hi, my name is Roland Johnson and I implemented the user interface for the BLARphone system. Within the BLARphone, there's a 56-key miniature keyboard and a 40x4 alphanumeric LCD. The purpose of the keyboard is to allow the user to type text data, which is then stored in the BLARphone system and then stored as an entire package which is sent to the next BLARphone. Whenever a key is pressed on the keyboard, the actual character itself is mirrored on the LCD, which allows the user to see what he has written. On the LCD itself, the 40x4 LCD, the top line is reserved for important information that may be necessary for the user's survival, such as battery status, message alert, or total number of messages received. This allows the additional 120 characters to be used for the text data itself. As well as writing simple messages, the user can navigate around the BLARphone with a control menu and with function keys. This includes starting a new message, continuing an old message, reading a message that has been sent and received by the current BLARphone system, and of course to activate the beacon mode.
I have a suspicion my friend is stuck down a cave.
To set up the BLARphone, everything you need is enclosed in the Velcro pouch. This has banana leads, crocodile clips and tent pegs.
I need a mallet.
First you hammer the tent pegs into the ground as far as they will go. Then get the leads and connect them into the probes plugs in the BLARphone. Attach crocodile clips to the other end of the lead and then connect it to the tent peg. Now your BLARphone is set up and ready to be used.
Once the BLARphone is turned on, you can enter the messages you want to send using the keyboard. These characters are echoed onto the LCD. Once you have entered the message you want to send, you press enter to propagate the message through the ground to the other BLARphone. When a message has been received, a message received indicator is shown at the top of the BLARphone. This can be accessed using the BLARphone menu screen, as shown here.
Oh gosh! Somebody must be trying to message me! Oh, that's okay. It's just spam. And nobody likes spam. Oops. Put it on.
Not a scratch in sight. Go!
Is it gone?